1 2 1 2 test sound. We have sound. Let's record. Jesus. What's going on here? Let me stop recording just to check if it gets better. What's killing my CPU? Oh, it's OBS actually. It's OBS. Okay. Looks like I need a new computer. Jesus. Using... Let me check if there's something I can do. Yo, Zero. Okay, I was checking my CPU. It's too high usage. Probably I shouldn't have updated OBS because it's eating my CPU alive. So let me check if there's something I can do to yeah, it's not a new CPU, it's a Intel Gen 6 6 cores. 6? I think it's 6 cores. It's the usual one that I'm usually doing. And usually it's way lower than that. But I updated OBS earlier. And let me see if there's any change. No, it's not. It's the same setting, same video. Well, let's see. Nope. Let's see. Anyway, let's start this thing. Oh. Okay, I'm not recording. Probably it will help. And we'll see. Anyway, welcome guys. So, been a long time. Sorry about that. So we're gonna start the Milo build-ish first. I'm gonna do some of my own modifications on the Milo CNC machine. I've been talking about this machine for a while. I wasn't sure if I would build it or not, but yeah, you guys made me do it. So I'm gonna put my own twist on it. I disagree on some of the design choices, such as mainly the choose of lead screws or lead screws or whatever instead of ball screws. Hey Joseph, how are you, my friend? So I have my setup a little different for this stream now. So I have the YouTube chat over there. So when I'm reading, I'm gonna be looking there. I'm gonna use this main screen for the design. So it should be fine on the camera. What more? Yeah, we'll see. So yeah, as I was saying, I want to do it. I want to build this machine a bit with my acquired experience on the CNC world, since I'm a CNC machinist, and I made my own VMC, etc. Everything about CNC mills, it's about rigidity, or mainly it's about rigidity. So we need to make every machine we design for a CNC milling purpose. The first thing we have to take into account is rigidity. We need something strong, rigid, and then all the other factors. But first one, it's rigidity. We need mass, we need stiffness, we need all that stuff. Yeah, so this is going to be at first just the CAD and modifications parts, so I can so I can see what do I need to order in order to, when we start the build, I have everything ready. So first we're going to do work series just with CAD. I want to get this done as soon as possible. Hopefully it won't take too much, maybe 2-3 streams. So I can order in everything I need. It will take some time to get the stuff, especially on this Christmas time or season. And I want to get it ready and get it done, because after Christmas, then it comes the Chinese New Year. Should be by the end of January or February or whatever. I'm not sure about that, but then it's a problem, and I don't want to get this thing too late. So I want to order in everything I need as soon as possible, so we can start the build. Meanwhile, we're gonna continue with the Micron. I want to finish that machine as well. So yeah, let's get to it. Okay, maybe I need to lower my gain a little bit on my microphone. Anyway, so yeah, I'm a little bit clipping a little bit. Okay, so I bought LDO kit, as you guys know, or at least some of you know. So the LDO kit, it's a very nice kit. The only thing I'm concerned, well, there's the modifications I want to make, of course, the ball screws and shit, but one thing I'm not sure yet about this build, it's gonna be the controller or the electronics part. I'm not sure. From what I know, the included controller board on the kit, it's too weak, and there's a new BTT Skyla, whatever. I don't know where did they got that name. Coming out, I think it's on sale. It's for sale already. So, but I don't think I'm gonna buy it. From what I've seen, it costs about, we can take a look. Let's take a look. Okay. Okay, let me... Okay, I was checking this. We can actually close all of this. Oops. Not all. Give me a second. Okay, so VTT. Place. Okay, there we go. Okay, so yeah, this thing costs, it's not cheap, 84 euros. So I don't think I'm gonna buy this board. First we'll see. I'm gonna test with the included board at first, and then we'll see how it works out, because I know the included board sucks, because soon as we load the Milo firmware and stuff in, it starts immediately complaining about lack of memory. Hey Nono, how are you, my friend? So yeah, that's a bad sign. So with the firmware, it starts to complain with low memory, so that's a bummer. To be honest, I haven't looked into any alternatives. I know this one should be a good alternative because it has the new 723, the STM 700 and I think it's 723. Yeah, the 723. So that's a 550 megahertz processor. Should have a lot more memory. And maybe it's okay, but I'm not willing to spend 85 euros on something that I don't know if it's gonna work. It should be, because it's designed specifically for this machine, or mainly for this machine. We'll see. At the time being, probably some people gonna have it and test it already. I'm more leaning to a LinuxCNC board, which I know it's a workhorse. It's not cheap. It's gonna be twice as much as the Hey, the Reverend. Yeah. How are you? I'm good. Long time no see, guys. Sorry about that. So yeah, I'm thinking of buying a Mesa. It's something I've been willing to try since I built my first CNC machine, but at the time there wasn't many information available, so I kinda got scared. Oh yeah, that's nice. So yeah, I'm really thinking of getting something like a Mesa. I don't know by heart the names, but yeah, pretty much I saw something on this link, something like Ethernet connected one, a 7, let me see. Yeah, this one. 7i96X. I wish. So something like this, which it's connected via Ethernet, so we can basically, I believe, so let's not write this in stone. I believe we can run it on a Raspberry Pi using Linux. I think we can install LinuxCNC on a Raspberry Pi and connect it to this board via Ethernet cable and just act with it as a computer per se. We can have a big touch screen and everything. I know LinuxCNC is awesome. We can configure everything as we want. I know it's possible. I don't know about the information available. I need to do some research. But again, I would like to try. I would like to try the original firmware first. I heard it's pretty user-friendly. I really would like to give that a try, but I'm not sure if I need to spend money on another board to that end, or to that goal, to use it with the original firmware. I don't think I'm gonna do it, because I'm not willing to spend 85 euros, and then if I don't like it, that's 85 euros to the garbage, and I need to buy another one again. And yeah, I'm not feeling like that. So probably, and since it's something I would like to try, it's LinuxCNC. Probably I'll just go with, if I have to do it, I'm gonna go with the Mesa card and just go with that and go from that, because I want to finish this machine. I want to make the enclosure, the casa enclosure for it. I wanted to have like a professional CNC machine. I want to have it to have the controller, like a big screen where we have the controlling information, like the DRO stuff and all the controllers, preferably a touch screen, a big touch screen, like a 16-inch or something like that touch screen, and with some physical buttons, like of course the what I call the holy shit button, with the big red button. It's the holy shit button when shit goes sideways. I would like some potentiometers for the feed rate and the rapids speed. That's so the feed rate override and the rapid override, because I'm used to that on my CNC machines, and it's awesome, where you can control on the fly the feeds to see if everything is starting fine, and when you see everything is fine, you go for it and throttle in. I would like a start, a stop, a pause button, a physical button as well. Not a stop, so a start and a pause, a cycle start, a pause, maybe some other stuff, not too fancy. I would like, I don't know if this is possible with the original firmware. I would like a pendant, so it's basically a handheld wheel where you can jog the machine. Basically, it's a remote control for the machine. It's very, very useful, and I'm not sure if it's available on the original firmware, but I know it for sure. It's available on the LinuxCNC Mesa stuff. Anyway, that's for the future. We need to get this thing going, build it, and then when we get to that part, we'll see. First, I'm gonna try it I'm gonna try it with the original stuff, then we'll see. One more thing that I'm considering very much is changing the motors. I have stronger motors available here on my shop from another machine, but I'm considering closed loop hybrid steppers. I'm not sure if I'm gonna go with it from the beginning. Probably, maybe not, we'll see. Hey Beanie! So one thing I need to get in consideration, it's those are bigger, are longer steppers. It's the same frame, it's NEMA 23 as well, but they are longer than the original ones. So I need to take that in consideration when I build the enclosure, or when I see the enclosure. I need to check if the enclosure, the existing one, it's like very tight to this machine, or if it has some room for the bigger motors. It's important to get that in consideration. I'm good, Beanie. What about you? So one thing I'm not, I don't think I will put on this machine is the handles, the manual handle, so you can control it manually. But that I'm not sure yet. Jesus. Yeah, okay. We'll see. I'm seeing frame rates, frame drops. I need to get a better computer for streaming. Probably a desktop. Anyway. So let's get started to the design. Where is my... Well, it's not this one. Nope. Top camera. What happened to my... Okay, okay, yeah, I see what I did. Okay, so let's see where the... maybe on this corner. And here. Nice! I'm not sure if that's good news, but... Where is my mouse? It's here. Okay, so... I have the original machine here. First thing I want to do is to design a functional machine instead of having all these fancy, everything perfectly designed with colors and screws and shit. So what I'm gonna do is just I'm gonna build the machine in blocks in order to study the movement, because we don't need all the detail that these guys put in to work with the machine. So I'm just gonna have this one opened for reference, and I'm gonna start a complete new machine because I can't handle that. So yeah, I have some stuff done already here, but that's for later. So yeah, let's start with the base. So first, and actually only the frame. I don't need all these parts here. Okay, let me see if maybe they are table skirts. We don't need any skirts. We don't need any electronics. So first I'm gonna start with Jesus. Hey, no. Got there something not right for sure. Yeah, okay. That's weird. I haven't checked that, Beanie. And sure, Nunu, ask about. And AZ Cowboy 1, how are you, my friend? Yes, I enjoyed it very much. It was fun. What did beeps? Okay, here on stream shot. Okay, let's see what's the... Let's see what Nuno sent us. Okay, let me... here? Yeah, here. Okay, let's add a new window. Okay, let's see what do these guys... DC heater. Let's see what's this. Oh, okay. I thought it was something. It would be something way more sketchy. Yeah, that doesn't really matter. Yeah, I see what they're doing. Yeah, it looks good. Yeah, it looks good. No. I don't see any... I would do it. No problem. You can always... let me see if the heater itself has some protection on it. Should have. If the heater... Oh, okay, it's one of these. Fuck off. Let me see if they have some... Well, one thing I would do... Let me just see this one, but I have one of these actually with me. I believe. I have one of... Give me a second. I think I have one of these heaters. Ah, I'm a sleeper. I'm not sure where. But I know I bought one or a project. So one thing you can do is to make sure, oh, it's there. I see it. So you can put the 350 watt, doesn't really matter. So it's one of these thingies. One thing you can do, it's just add if you use one of these, just add a safety thermostat like this one. So this is a mechanical thermostat or a thermal fuse. A thermal fuse, it's more permanent, but you can use a thermostat, something like this, when it gets to a certain temperature, like, I don't know, maybe 100 degrees, it cuts out. Then when it drops to, I don't know, maybe 90 or something like that, it starts again. So it basically doesn't allow the heater to get higher than a certain temperature. And these, when they fail, when they die open, so it kills the power. At least all of them. I seen quite a few of these guys dead, and they all died open. So if they die, it just doesn't work. The heater just doesn't work. Yeah, and you'll be fully protected in case of the sketchy thermistor or something like that dies or reads wrong the temperature. You're always safe because you have this mechanical one that will die or will cut off or keep at a certain maximum temperature. You can buy one for like 70 degrees or whatever you... Well, yeah, that's something you can try first, because the idea, you can also control, well, you can't control, but you will control the heater with the thermistor on that controller thingy, so on this thingy. So this thingy, it's basically the PID controller. So it's gonna have the thermistor. We will attach it to the well, I would attach it to this thingy. Well, these things have these are the ceramic ones, so these things have a plus, which is once they don't keep heating until they die. They will heat until a certain temperature, and then it stops there. Yeah, that's something you should consider. Instead of putting the thermistor on the chamber, putting in on this, and that way you guarantee that the air, it's constant at a certain temperature. But yeah, I would test it first. I would test it as a chamber thermistor and see how it goes. And you can always add one of these to make sure that this thing never gets higher than, let's say, 120 degrees. I'm sorry. Or something like that. It will always keep this thing not too hot. But yeah, for sure. That's something I wouldn't have no problem on doing that on my printer. let me see how is the so the parts itself. Let's see if there are more pictures. Yeah, should be fine. I would like to see where the because you won't have close contact anyway with the PTC. So yeah, you should be fine. I would just add that thermostat thingy just to be sure that the heater never gets higher than something around 100 degrees or so. Other than that, yeah, it should be fine. Okay, so let's go to this thingy. So as I was saying, I want to build yeah, exactly. So let's do this block. So this thingy, let's start this way. This thingy is how long? Okay. So we have 550. So I'm seeing the number in here. I selected both faces, the front and the back. So we have 550. We should have 60 here since this is 20 millimeter frame. Yep, 60. Okay, so let's start with a C block. Okay, like that. L for line. So let's start 60. Shit, I forgot the width of this thingy. So here to here, 240. So we're gonna go 240 this way. We're gonna go low. Let me do the rough shape first. Then we take care of the rest. So we're gonna do this one, collinear with that one. We're gonna press D for dimension, 20 here. This one, we're gonna call it the same as that one. And this one the same as this one. And we have a C shape, so now we're gonna press E for extrude and 550. Okay. So we have to push the ends a little bit. So let's put it like that. Let's see, it should be 20. No, actually it's 15 difference. Okay, so let's push them 15 out. And let's do the same for the other side. Probably it's the same. Another CG. How are you, my friend? Okay, so here to here. Yeah, 15, same thing. So let's do the same thing. I should have done a new component, but Okay, so E for extrude 15 outside, like that. Okay, so this is the base. Let's call it, let's create a new component here, and let's call it base. Now now let's put let me hide this motor. So I'm gonna press it and V for disappear and V. Okay, so now let's make this C section on top. So this is a full piece of frame and it's 80/40 because this is 20mm frame. So let's see where it stands. So it stands here, 70mm from the back, and it's 470 long. Okay, so I think okay, I think I'm gonna, yeah, let's make it separated. Okay, let's create a new component. This is what I should have done in the first place. So let's call it Y saddle, because it's where the Y axis will move in. So let's make a rectangle here for 70, as we said before, and 80. Now I believe this thing is centered on the frame, so the distance from here, yeah, it is. Okay, so I'm gonna create few points, few midpoints. So this rectangle, this triangle in Fusion, it means it's a midpoint. It means this point is on the middle of this line, and the same for this one. So now I can make these two guys aligned to each other, and I can say that here, I believe it's 70, right? I think it's 70 that I said before. So let's take a look. From here to here, yeah, 70. Again, I'm looking here, this corner. So I'm gonna extrude 20mm to the top, because again, this is frame. Okay, I pressed somewhere that where I shouldn't have. Okay, so let's make the other parts. Okay, let's make two lines. So this symbol means that this line is perpendicular to this one. So now we press D for distance and or dimension, and we do a 20. We call the same one at that one, and we press C for extrude, and we do 20. Boom. And we have the Y saddle. So this one it's moving. So what we're gonna do is we're gonna press this one and this one. So I'm holding shift when I press the different components, and we can do shift J, or shit, okay, let me select them again. Or we can go here to the assembly and as built join. What this does is it will stick one to the other where they are right now. So now I can't move any of them because this one, you see that little anchor there? If I do unground, that means it's grounded. So it's stuck. If I unground it, now if I move one, it will move both of them. Okay, let me ground it again. And now I can't move these things around. And I needed to present no references to join the two components together. Okay, let me save this file. I'm gonna save as functional assemble. Okay, now on the saddle, one thing we can do is we can design the rails on it. So basically I'm just drawing everything that is stuck into place and as simple as possible. So instead of designing the rail with the screw holes and the screws and whatsoever, and the frames with the slots and whatever, doesn't really matter for our study. So what we need is just plain and simple stuff where we can do movement around and with no fuss and no complexity. Doesn't really matter, doesn't help at all. Okay, so we have 350 rails, and what can I do? So what I'm gonna do is I'm gonna long press here. So if I long press, I can select hidden stuff. So I want to select that face, and I want to see how far away it's from here. So it's not a precision placement here, so I assume it should be at about 81 millimeters. Let's check how it's in the front. Yeah, it's probably a little bit into this printed part. Well, it doesn't really matter for our thingy. So what I'm gonna do, shit, I forgot. I think these are 15 mil rails, right? Come on. Yes, they are 15 mils, and what's the height? I should be able to select this face. Yeah, this face. Shit. Okay, 10. They are 15 by 10. Fine. Okay, so we press R for a rectangle. We want 15 on that side tab, 350 on this one. So we know they are about 80.8 millimeters from here. and we know they are centered. So I'm going to put 2 points again on the midpoints, and I'm going to align them. If you guys have any questions of what I'm doing or how I did something, just ask. I'm just working with some good flow here. Okay, so we're gonna do the same for this thingy. So I'm gonna press P for project in order so I can have another. I don't know why I'm having publicity or advertisement on my Spotify, but yeah, looks like there's some kind of bug because I have premium. Anyway, okay, so I pressed P to project that face there, so I have the references, because since I'm designing on this plane here, it doesn't recognize this one. So I made another rectangle. I'm gonna call this dimension, and what's the best way to do it? Okay, I'm gonna align these two collinear, and I'm gonna align these two as well collinear, so they'll be the same length. And since they are centered, I'm gonna do the same thing, midpoint, midpoint, align them. Okay, this way, if I do any change on that one, let's say I want to change this one to 85. I made a mistake and it's 85. It will change everything at the same time. And if I made it the wrong length, let's say 325, it's gonna change both of them. It's easier and much more simple to change stuff if we do mess up. So since we need to extrude these 10 millimeters because they are 10 millimeters high, and there we are. 2 rails assembled, nice and easy. Okay, next. Okay, next we're gonna need a new component. So let's put the new component. Oops. New component. And we're gonna call it what? I think this is called the saddle. Let's call it X saddle, because it kind of is. Okay, mods. The most important mods I'm gonna do, it's definitely the lead screw replacement for ball screws. That's the most significant one. Well, not the most significant one. It's the major one. Let's call it the major one. And then it's only about rigidity. Because let's take a look. So first, okay, I need to check how is the so the LDO kit comes with what they call the full metal jacket mod. Basically, it's 2 side plates on the Z instead of these 3D printed parts. So it's 2 metal side plates, full one piece. And I need to look at. So what I plan to do is, first, I'm not gonna use the the bottom side, the bottom part as electronics bay. So this thingy, it's gonna be completely full, completely filled with epoxy granite. That's the one thing, to make this base one stiff block, heavy block. Then this is this I need to look first, but I'm pretty sure I can do that because this is open. I want to fill. So when I say this bottom part, I also want to fill the holes, the side holes here. So this hole, I want to fill this junction here as well. I'm not sure if I'll be able. Yeah, I will be able. And all of these hollow pieces here, this junction. The idea is to make this thingy one single block as dense as possible. So I want to fill all these hollow pieces here. But for that to have any meaning, then I need this section, so this C section here, to be as how do I say it, as glued at the base, or gold filled would be nice. If I had that amount of gold to put on this thingy. So I want this piece to be as attached to this block as I can. So I'm thinking of two options. First option is make a corner bracket all long as this piece is, but it's going to be, the idea it's not to increase the price. So the cheapest thing I can think about it is just to make a dam somewhere, something like on this shape, like from here on the top to here, and fill all the gap in order to fill this slot and this slot with this slot and this slot with epoxy as well, epoxy granite, so epoxy mixed with sand. That's the ideal and that's the cheapest, but it's not easy to make. So I need to get creative on, but I need first I need to design, to continue the design and make sure. And of course, if I fill that, I'm going to fill evidently these two gaps or these unions here, these slots here together as well, to make sure everything, to make sure this top C section gets the most attached as possible to the bottom base, because that's this is the base of the mill. It's what it will support the full mill. So the more rigid this block is, the better will the mill behave. The less hollow aluminum frame it has, the best it will work. It is like that. It's just like that. It's going to be heavy. Yes, heavy is good on a CNC mill. So yeah, I'm gonna do the same on this part here. This is absolutely nonsense. So these are 3D printed parts. Let me put them on another color. So we can see it better. So this is absolutely nonsense. Yes, I get it. It's the cheapest way. So let's 3D print some corners, some corner brackets in plastic, and let's put them joining the. So this is a C section as well. Let me move this away. Shit, not that. Sorry, not this one. Yeah, I fucked up. Let me Control Z. So V and V. So this is a C section, like the one on top of the base, and they just widened it. I'm not sure why. Well, I know why. It's to have a wider table, so you can fix shit, because you have a 160 travel, I believe, on the Y. But yeah, so this is the stuff that is actually on the rails, and then these two frames, so these two side frames, are attached to the main piece with plastic parts. That's not ideal. So my idea is to do the same. It's to do something on this shape, but just do like a mold and fill this thingy with epoxy granite as well. So what I'm gonna do, I'm gonna use maybe some profile bars to align everything here on top. We'll see. I have some ideas for this. So probably I will machine some straight edges to catch here with screws in order to keep the whole table flat. And then I'm gonna make some kind of wall here in order just to fill it with epoxy sand, with epoxy granite, in order to get the epoxy in here and here and here and solidify the whole thing as one. And of course I'm gonna fill it as well on these gaps, these gaps, these gaps, these gaps, in order to fuse everything in one block. That's the idea. And it will be much stiffer, much stiffer, much stiffer. One other stupid, completely, absolutely stupid thing is the LDO kit, this is a mod as well, includes a fixated, they call it a fixated plate, which is, well, it's this one, but this one it's modified by me. I already modified it. So, but I can show it. I can show you how it comes and what I did to it. Well, you guys see already what I did to it. Okay, so this thingy, it's supposed to, let me align it just real quick. Come on, align components. Everything is black, kinda. Okay, that's good enough. So let me open the thingy. Okay, so basically the original one. So this is the original one. So it comes like that. Each of these holes it's threaded M5. And this thing it's supposed to grab only on the on these slots. So they use 2 clamps with 4 screws to attach the. It kind of makes sense, but it doesn't. They use two parts that fit in these slots with 2 screws, which will attach to the frame, just on the ends. Why? You're putting a 10. This is 10 millimeter thick. A 10 millimeter thick aluminum plate on top of the table. Why don't you? So these, I modified these to accept. So these are supposed to be rimmed holes for alignment, M5, 5 millimeter holes, so we can put dowel pins to align stuff. And here it's supposed to be screws, M5 screws, attaching to the table. So why not put a bunch of screws attaching everything together in order to increase rigidity? Makes no sense. Don't ask me why. So what I did, I added a bunch of screw holes. I'm not sure if I'm going to use all of them yet. This is just a rough design. So, but why not use the table to increase the overall rigidity of the machine and screw everything together as much as you can. You guys may think this is a little over screwed, but I don't see any problems with that. I prefer it to have way more screws than I need than not enough. So I think it's very stupid only using 4 screws to attach this whole plate to the table, especially if you're probably gonna have either a not flat table or plate or a not flat profile on the bed. So if you only screw it to the ends, it's fine. If your plate it's like this, so you will force the middle or you'll force the ends towards the frame, that's fine. But if it's both the other way, then it will be the middle, it's going to be on air, and it makes no sense. But yeah, that's just me. What do I know about this? But it's a major flaw in my opinion. So yeah, I'm gonna this is something I want to do for sure. It's to eliminate these printed parts here and make a dam, so in order then to fill everything with epoxy granite. When I say epoxy granite, it's epoxy mixed with sand, in order to glue these slots, or in order to make this one big block. And if we then also fill these hollow parts, especially these ones where the frame gets together. It's gonna increase so much the joint strength that's actually incomparable. So everything hollow in here should be filled, and yes, you will increase the weight of the table. That's fine. That's fine. It's kind of cold here, and I'm thirsty. My throat is dry. I need to go drink something in a minute. But yeah, that's the main modifications I want to do. Of course, I'm gonna do the same at the column. So these printed parts gonna go away. I don't even know what's this. So this thingy needs to be filled with epoxy, everything we can. Same here, increase the joint strength. I get it why they did it this way, but we have 3D printers. Instead of printing these plastic pieces, we can print dams or molds or whatever you guys want to call it, to actually fill this with epoxy. Everyone can mix epoxy, everyone can buy a bag of sand, dry sand, a nice quartz sand used for the filtering on the pools. You can go to a dam store like we have the Leroy Merlin or the Walmart or whatever, and buy a bag of filter sand for the pool, mix it with epoxy. You don't need fancy tools to do it. You just need to mix it. You can even buy a mixer for the screwdriver or whatever, or even mix it by hand. It takes a little more work, but it works. And just fill it with the epoxy. It's going to be completely do-it-yourself anyway, and it's going to be much better than printing the parts with print these parts and use them here. So, or 3D print a mixer as well. It doesn't need to be, I know ideally you want the less epoxy the better. If you need vibration, you can buy a cheap a sanding machine, the vibrating ones. You put it next to the table, and the vibration of the sander, it's more than enough to accommodate the glue. It's easy. Hey, Angelo. So, yeah, and it's not that expensive. Yeah, of course you need to buy, I don't know, maybe 5 liters of epoxy will do for the whole job. Pretty sure it will do. Well, if it vibrates hard enough, it should work. And it's not even the adding weight, Reverend. It's adding rigidity, because it's not like you're screwing in some pieces of lead to add weight. It's really to increase the rigidity, because you'll get the blocks all together, all fused together, and acting as one. So it's a win-win situation. The weight is just, well, according to them, weight is bad, but not according to me. I mean, they called me crazy because it would be too heavy to add the weight in the table. Well, it's too heavy, and then they complain about too heavy, and then they use 8 millimeter pitch lead screws. So yeah, you guys take whatever you want from that. So anyway, moving on. So let me continue my design. I'm gonna delete the fixture plate from here. Okay, so don't save. Okay, so now we're gonna get to the part that I actually want to export this plate. I assume this plate is the exact same that comes on the LDO kit. So XY gantry plate, that makes no sense, this name. Okay, I don't want all those screws. So I'm gonna create these as a component, and I'm gonna export it. Okay, I'm gonna call this saddle plate. And I'm gonna export it to my functional assembly. Okay, and I'm gonna put it in here. Oops. Something went wrong. Okay, I need to rename this. Oh. Saddle plate. I don't know what I've done, but surely fucked that up. Okay. So this is supposed to be like this, I believe. Need to go check. Yes, so yes, that's exactly. So well, it doesn't really matter. Can be like this or the other way around, should be fine. According to the design, M for move, it should be like this. Doesn't really matter. So now we need some carriages. And actually, I might... yeah, I'm gonna do a carriage on a different design. It's easier to import. We're gonna need a bunch of them. So let's do a carriage. Okay, when I say a carriage, I say one of these things. So these things have 42.10 and shit. Come on. $32. Hey, Kegel. 4210. How am I designing these? Shit. Oh, doesn't matter. So 42.10, 32, fine, and from here to here, 12 millimeters. 12, fine. Now we need to, yeah, completely fucked up, doesn't really matter. R for rectangle, 15. Let's create some points, midpoint, midpoint. Let's align the midpoints. It goes slowly but steady. Okay, so now I need to find from here to here. These at 6 millimeters. Okay, so let's do extrude minus 6 millimeters. And now we need the whole pattern on these thingies. I'm gonna assume we're gonna need a center rectangle, create points, duck, hit, create point, another middle point in here. I'm gonna align this one with this one and this one with this one. Now we have a centered rectangle. I'm gonna press X for construction. And I probably, okay, that works. That works. Inspect. Snap points. We have from here to here, 25, here to here, 20. Okie dokie. Okay, so we have 20 here. And 25 here. Oops. And now we have probably 3 millimeter ones, right? Radius 123, yeah, add M3. M3, so let's put 2.5 millimeters, 2.5. C3. I'm gonna call it I like to reference all the dimensions that are the same to the same one, because if I need to do, it's not the case, but if I need to change all these holes now, since they are all referent to this one, if I change this one to 5, it changes all of them. So it's going to be easy to change stuff if we need to. And I forgot to, let's grab it. Let me see how deep they are. 5 millimeters deep. Okay, so what I'm doing, why am I doing all of this? Because I want to do a simple model, a simple functional model that I can move around. I can make slides and all kind of joints to see the kinematics of the machine, so I can figure out if anything that I'm gonna do will hit when I move the machine all the way to one side or to the other. So I want to do a functional, simple model, a simplified model. So I'm gonna call these MGN 15. It's probably age. Who's calling me? And why? Okay, so now I have this thing in there. Where's my mouse? 3 monitors. My mouse, okay, it's here. Okay, so now we need 4 of these thingies. And they are like this. Okay. Now I'm gonna copy, capture position, boom, and now I'm gonna copy these two, and boom. Oops. It's not what I want. That is what I want. Okay, so now if I join one of these thingies in here, press J, all the holes should line just fine. So let's do the others. So I'm pressing one hole. I need to make sure it's the same hole. Press J for join. And they all go together. Hey, Questionable, how are you, my friend? Okay, J, fine. And now, this is the purpose I'm doing. I'm having all of this work. It's exactly this. Now I can go and make a joint. Not that kind of joint, but a slider. Now, I'm not very used to how they changed this a while ago, and ever since, let's see, that's it. Sometimes it's a little finicky to make it do what I want. Let me see, that's it. And now you see, now this thing slides on the rails we designed. So now I'm gonna align here, and I'm gonna check the distance to here. So we have 227. Yeah, been very busy. So technically we have 228 millimeters of travel on Y. So we're gonna go with that. If we light up the joints, so here we are at 0. If we double click, that's the joint position, and it gets positive on this way. So I'm going to right click it on the joint and I'm going to edit motion limits. I'm going to do the limit of minus 200 and what? 28, right? And the maximum of 0, the rest doesn't matter. And this way, now our part doesn't move out of the rails. Okay, now we need 4 more. Okay, can I create a folder? No. Nope. Okay, doesn't matter. So we need 4 more of these thingies. But now we need them like that and like that. Same story. J. No, but now we don't want slide, we want rigid, like that. This is going to be fun to assemble. Now that I'm watching this, yeah, this is going to be very fun to assemble. Chain. Oh, which one did I? Okay, that one with that one. Okay. So now we have everything. Let's hide the joints. I don't quite understand why. Oh, it's probably, I don't know. Why these? Doesn't matter. Gonna hold that one as well. Gonna leave that slider. Okay, so now we need another component. And now we gonna call it the table. Why is it? Oh, I fucked up here somewhere. Oh, because I'm on sheet metal. Okay. Makes sense. Okay. Table. Well, the table. Okay, let me delete. Oh, okay. I see. Why you are not inside there? Should be. Okay. Okay. I don't know why, but they should be in here. So I'm going to create another component in here, which will be the table. And new sketch, we're gonna use this plane for now, doesn't really matter, so we need to move around. So it should be something like this. I'm just doing the rough shape of the table. Okay, some stuff I do know. I do know that this one, it's 20 millimeters. This one should be 80, 120? No, 160. 160. Yeah, okay. This should be 40. This should be 20 as well. This one should be 20 as well. This one should be 40, I believe. And this one should be stuck. Yeah. Rate driven. Yeah, that's fine. Now, this one should be collinear with that one. This one should be 40. Let me call this one the same as here. Oops. And this one should be collinear with that one. Should be something like this, right? So what I did, I just shaped. Oh, no. I'm wrong. This one, it's 20 as well. Shit, that's a problem. Yeah. Yeah. Yep. Okay. So what's the length of? They should be all the same length, 500. So let's extrude 500. And we have the table. And now, oh, we have it's the same length. Oh, it is. Oh, okay. So since the rails are the same length, we can add them in here. So L for line. Those two are collinear. D for dimension, 15. This one, it's the same as this one. Create point, midpoint, 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 vertical, vertical, D for dimension, 10. Hey, Alan. Alan, right? Yeah, Alan. I'm running right now. I'm not running anything. So I'm gonna start with the spindle that comes in the in a kit. So it's a 1.5 I RPM Spindle, a VFD one, variable frequency something. But the idea is to later on replace it by something more do-it-yourself. I'm thinking something like ER2, ER20, maybe ER22. ER20 should be plenty. A ER20 power head with something like maybe a 2 kilowatt servo, so we can do some fancy stuff like threads and, well, we can do threads anyway, but rigid tapping and that kind of stuff should be fun. Okay, so now we have the table. We can do another joint, a slider, and if everything is in position, we should be able to put this guy. So what I'm looking for the, I can zoom it, this reference for the Z, so that's the blue line. Maybe if I rotate it a little bit like that. So the Z, it's on the direction I want it to slide. So I'm gonna slide that corner with this corner. See, we have the blue line on the same axis. That means it's gonna do what I want it to do. See? So same story. I'm gonna do the limits. Align. Shit. What if I? Okay. Why don't I see the? No, it's not this slider. Why can't I? Oh, it's there. It's very faint, but it's there. So from there to there, so 340. So it's at 0, so it's the same thing, minus 340. Edit motion limits, minimum minus 340, maximum 0, and oops, actually it's not the same story. Huh. Oh yes, because it moves to this side. Yeah, my bad. So I need to edit, and it should be 340 and 0. Hey, TrueRex. Okay, so there we go. We have a dancing table already. So actually this is the front, right? Yes, this is the front side. So another change I want to do is the end stops or the ohming or the ohm switches. I don't want to use, I need to see, do this thing as ohm switch limit switches or no. Okay, so it only uses ohm switches. Okay, I don't want to use mechanic ohm switches. I want to use optical ones. So that's something else I want to change. Boa, Jota. Obrigado. So my friend Jota just came in to say hi. Give it a like. Okay, so let's get to the column now. Okay, so now I'm gonna go back. Actually, these two should be inside the base, but it doesn't really matter. I'm gonna go back to the main assembly. And I'm gonna create another component. It's gonna be the column. I think it's like that. Okay, so the column. How is the column designed? I don't like this all black. It's very dark. So let's hide it for now. Okay, so the column rests on top of the... Ah. Really? Interesting. He's running the kind of spindle that spins. Well, hopefully. Hopefully. Hopefully it spins. Okay, so... that was a good one. Jesus. Okay, so let's see. So it burns from there. Okay, let me hide this guy. V. Oh, Jesus. Okay, so these are two C-sections. Against each other. Okay, I see. So I'm gonna do a square. Yeah, 80, 80 square. So 80, 80. And then another square for no 6, right? 60, not 460, 60, no, 40, 40. Point. Jesus, I'm not even gonna try to say your name because I'm gonna murder it. Hey, how are you? Okay, I'm gonna do it separate. Even... Whoa, 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 whoa. Okay, I see. Okay, but I need to get a name for you. So, Mayuresh. So, how long is this thingy? That's the question. How long is this thingy? So this thingy is 260. So is this 260 the... Okay, we'll see. Well, at least I got that right. So 260. Okay, I need to check if that's because the Milo it's modular, and they recommend a maximum travel of Z of 120, I believe, with the full metal jacket, because with the regular, probably it's just this piece that changes the size. With the 3D printed parts, they recommend 60 millimeter travel. So I assume the column is the same size. Actually, pretty much everything can be the same size, except the rails here, which should be smaller. But yeah, I'm gonna assume that's fine. So what do we have here then? Then we have another C-section, or C profile, 120. Okay, let's do that. So we're gonna start here, and this one is 80, no, 40. Like that. We put the 40 to the other way. 20. More 20. Now 40. What have I done? Yeah, 40. And 20. Let's do it all. And 20. And like that. A for extrude. Minus 120. Okay. And now I think we're gonna start from here. And same story, another C-section. Let me check. Oh, actually it's higher. Oh, okay. Never mind then. Okay, so I need to check how much higher. Let's disappear this guy. Looks like something like 20. 18. Okay, 18. So we need to create a plane from this guy on that side, so minus 18. And now we need to create a sketch on that plane. Let's project P for project those 2 points. So we have a reference 40, 20. Okay, let me do the rough profile first, and then I'll add measurements. So we want this to be perpendicular, this perpendicular, this 20. We need this and this collinear, and we need this one to be 20 as well. Done. And how long? To 50. Fuck. Edit. Minus 250. Okay, like that. most likely. Okay. Yeah, okay, so the Z rails are the same size, so that means we can actually add them to our design here. So same story, just doing sketch the rough shape. This one will be like that one. This one will be 15. This one will be same as this one. And this one will be 10. And we need points. Point here, midpoints to be specific. So we can align them and align them. Nice. And now we can add that to our extruder. Okay. And we have our rough shape of the column. Now we need the Z plate. So let's export this guy. Z axis, Z mounting plate. Give me a second. Fuck, I don't want all those screws with it. So I'm gonna create a component from this body. And I'm gonna export to the functional assembly Z plate. Okay, we're gonna put the Z plate inside the column. Okay, so again, this plate is already supplied on the LDO kit. I'm assuming I'm gonna grab them in a Thank you, my friend. Shit, I lost my Okay, I need to check we're gonna grab them in a few minutes to check if the plates are exactly like this, same size, same drills. Should be. And they are supplied on the LDO kit already. Okay, we need 4 of these guys. Again, actually on that orientation. Control C, Control V. My kit came from 3DO. It was the cheapest what I found on the on Europe, and I bought it on the Black Friday promotion. It was like about 200 euros, a little more actually, cheaper, about that. So yeah, I think those 200 euros will cover the cost for the mods, like the epoxy, the ball screws. So the regular price it's 1,400 and something, about 1,450 ish, I think. And with VAT. And this one with VAT should be about 1,200 and something. What do I want? J. No, I haven't finished the Micron yet. As I was saying earlier on the stream, so I want to finish to make the CAD for this project now, so I can see what do I need to order from China, so I can order the stuff soon as I have the CAD done, so I have all the dimensions for the ball screw. Mainly it's about the ball screws. In that way I can order the ball screws or whatever do I need for the build, and then I'll finish the Micron, so I can orient the jobs like that. So when I'm waiting for one stuff, I'm finishing the other. Right now what I want is just to finish, see what I need to modify on this one, and order whatever I need, and then I'm free to finish the Micron, and while I wait the other stuff for this one. It's not that I'm in a hurry to start or finish this build. This build is going to be a long one. It's just so I can get things moving. So I need a joint, I need slider, position, like that. And then, oh. Continue. Okay, what have I done wrong? Let me see. Okay, let me delete this slider. Oh. Okay, I see what you mean. Okay, I need to, yeah, okay. I see you. Ah. Okay, let me try if I can do this. If I can do this and Shift J for rigid. Okay, no, I can't. Fuck me. Okay, I forgot to create. Oh, should be okay. Okay, let me create. Let me go back. Where did I put this guy? Okay, here. Roll history. Why don't you let me roll the history? Okay. Yeah. Okay, I forgot to create component here. Yeah, I'm gonna call it column as well. now should be fine to create a joint slider. Nope. Ah, because they are anchored. Okay, I'll fix it. The Z plate is grounded. Okay, that's the problem. That was the problem at the beginning. The Z plate, so the Z plate was, let me, you see that anchor there? Since it was anchored, it can't move. Now it can. Hey. Why? Okay, I forgot to do rigid this one. Yeah, that's it. Okay, let me do it when it should be done. So it should be here. So let me roll the history here. I'm gonna select this one and this one. Shift J for rigid as built joint. And now let's move the, there we go. Same story. Align. Let's check so 0. It's moving up, we need to move down, so it's negative. And how much negative can it be? So 126. Right click, edit motion limits. So maximum is 0, minimum it's minus 126. So that means in theory, this machine has 126 millimeters travel in Z, and I don't remember how much it was on. Okay, let me enable everything so I can see actually. Huh, not here. Oh, it's there on that side. So these are the mechanical travels. So it's 340. Oh, I thought it was 360. Okay, it's 340 on X and $228 on X, but probably, so it's less because otherwise you see what's going on in here. The table would crash with the column. So if we align, this, we have 210, so maximum travel. So where do the other 5 centimeters go? Why do they make it so long? Well, we'll see later. With the spindle and shit. Okay, so now it's a good time. Let me grab the... I'm gonna grab the plates from LDO so we can check if they are the same as the drawings, if they have any changes. They should be. It should be the same. So cable kit, long john, electronics. I have some stuff in here. Let me see which one is the box we need. Hopefully it's this one. The box within a box, within many boxes. I'm not a small guy, but I'm a little small. Okay, so these are the let me put in the top camera. Yeah, there's a new revision. Of course there is a new revision because I bought this one. It's always like that. Okay, so this is my screen. It's a little bit on the way, but so these are the side metal plates, which I need to find the model to put them in on my mock-up model. They look very nice. Okay, so these are plates. I'm pretty sure. Pretty sure I saw them. The plates I'm saying, maybe they are on the other box, which is a bummer. Okay, let me try something. At least now I can show you something that's very stupid on this design. Okay, let me check. So this is the hardware kit. Oh, it's there, it's down there, I see. Okay, this is the hardware kit, so check this out. These genius guys on the internet, what these guys are thinking. Okay, let me get back my shit. My camera. And my screen. And my front. Okay. So, this is a ball screw, a lead screw that these genius guys are using. So these are 8 millimeters, 4 threads, and 8 millimeter pitch. So take in mind that on the end of this thingy should be a motor, and the other one should be a bearing. Doesn't really matter. So So there's a nut in there. Let me fully thread it. Actually, this one has a little friction, but it will work. See? I'm doing nothing. Now I'm just tapping on the screw. See? Just tapping. And you see the nut is falling down. So that means there are so much force transmitting from the where the hell the whatever it's holding the nut to the lead screw. So to the rotation of the lead screw, actually it's not to the lead screw, to the rotation. And same as the motor in this end will need to hold that force back. So because with the milling it's not like a 3D printer. The 3D printing, the holding forces implied are from the weight of the head. Unless the head hits something which it shouldn't, there's no forces to deal with on a 3D printer. But on a CNC machine, that's a whole new thing, right? Because you need to push the end mill or the drill or whatever against the material, and the material will fight back. You'll need to push the end mill there in order to rip pieces of it. So yeah, it will make much more struggle on the motor with these thingies than, and they could prevent that with just a smaller pitch lead screw. I'm completely against the lead screws instead of ball screws, of course, but I'm specifically against such a high pitch on the lead screws that pretty much the nut fall itself through it, because the angle of the threads are too open. But yeah, that's just a side mark. Just a side mark. Okay, that doesn't really matter. I believe the plates are on that box down there. What the hell is this? This is heavy. Oh, motors. So this is the power supply, CNC starter kit, and that's the VFD. Okay, this is what we want. Okay, let me move this away. Okay, so this is the fixture plate. As I said before, stupid because of the only grabs on the sides. Yeah, it looks exactly. We have. Oh, that's only okay. Okay, so we have a beautiful machined plate. It's well machined, very well machined. Not sure about the flatness, but we are working on Jesus. These guys know there are longer screws available. Okay, this is something I don't like. And it's probably not an LDO problem. Let's take a look at the CAD. Yeah, but that's fine. Yeah, I'm pretty sure it's according to the CAD, but okay, let's take a look. Let's take a look. And they both have the same problem. Jesus, these people are stupid. Anyway, okay, what I'm saying is, let's take a look. Let's grab this guy. And well, actually we can open it on the side. Let's open it on the side. Okay, let's check out. Let's inspect and let's do a section analysis. Look at this, look at this. Why? Why? Why do we have such a thick plate, like 15mm plate, and they leave it with a 2.25mm wall? Why? Ah, Jesus. Don't they do? I think they believe there are only 6mm screws are available. Yeah, I get it. Long screws are not the best, but thin walls are not the best either. So if these things were 2mm, so if these counterbores were 2mm shallower, so not so deep, we could use M38s, and at least there's not a chance of ripping a 2mm wall of aluminum. It's nonsense. It's nonsense. And it's like that in here as well. It's like that. Where is section analysis? It's the same thing. Look at that. Same story. Ah, Jesus. Anyway. And of course, LDO just machines to the drawing. They don't have a brain for themselves. And hey, let's give it a little more meat there. Anyway, it said, and probably same shit on this one. Same story here. These ones are not so important, but it's the same story. Yeah. It's nonsense. It's nonsense. There's no other way to say it. It's nonsense. On this side, that's fine. On this side, there's no problem already. So now, okay, here we can leave 6, but on that one, yeah, fuck that. Let's take it out. Take it all out. Why? It's not like we can't fit the screws from the back, right? Let me check. Well, in this one, there's simply no explanation. Yeah, there's plenty of space. Anyway, it is what it is, my friends. And I'm the dumb one. I'm the dumb one. Anyway, everything looks like it should, I think. So this is supposed to be 158, 110. Where's I just want a ruler. Shit, this one won't be enough. Yeah, it should be fine. Well, actually, they were smart enough to make it smaller, but not smart enough to... No, that's fine. That's actually very fine. Couldn't be a lot more accurate than that. So the other one... 125. This one actually it's a little smaller, but yeah, that's fine. Yeah, it's the same design. It's the same design. Same thing. Okay, that's fine. It's just stupidity of the designer, or mine, maybe, who knows. Maybe I'm the one that is wrong. I would love to hear the explanation on that one. Okay. Let those be. No worries. Let me grab the full metal jacket. Models. Okay, maybe I need to call it FMJ. Okay, this is the, okay, let's see, Millennium Machines, repositories. So fixated. Huh. Where can I find the damn model? So they don't, shit. Where the fuck? Okay, Milo.
Aproveite as vantagens de ida e volta neste Natal com o El Corte Inglês e a Repsol. Utilize a app El Corte Inglês ao abastecer na Repsol. Receba os maiores descontos por litro e vale de €100.
Did you miss anything? I don't know.
Só no El Corte Inglês, loja web e app.
I figured out, so I was comparing, maybe you can explain this to me. Let's see. So I was comparing the plates, the machined plates from LDO to make sure they are the same as we have in the design here. And I noticed something very weird. And of course they machined to spec. So why do you have give me a minute. So why do you have a 10mm thick plate and then you do counter bores until you have only 2.25 millimeters of aluminum of thickness here for the screws. So this is where the carriages, so why? The question is, why do they do that? And they did that everywhere. There's absolutely no good explanation for this. I mean, the other ones are fine. Of the other side, these ones have 6 millimeters. See, these ones are fine from the other side. That's fine. Probably, that's the only explanation. Maybe they have an extra supply of M36s. And, oh, Jesus. Or it's like Questionable Choices said to piss me off. And it's the same on the Z plate. It's the exact same shit. And here it's even worse because it's a 15mm plate. And they get it down to 2mm again. Why? Anyway. It's so fucking stupid. And they do the same here. Here it's not that important. It is important, but here it's even worse. It's actually 2mm, not 2.2. or 2.25, right? Yeah, 2.25. Ah, Jesus. These guys really piss me off. Anyway, okay, so I was looking for the Milo CNC. Okay, documentation. Frequently asked questions. Okay, they refer the full metal jacket, but there's no models for the full metal jacket anywhere. Okay, so looks like I need to make some changes. So they say, hey AR, so the 2 times 4080s are 320, and I believe they are referring to these guys here. Oops. Because I remember mine having yeah, 220. Okay, so well, I guess I need to check. There's no need to make them beefier, to be honest, because this machine doesn't have the strength to actually rip off especially with the motors they use. This machine doesn't have the strength to rip off those plates, I think. But there's simply no need to do that. That's the point. It's more machining time because you need to drill deeper. It's seconds, but it's actually more expensive. If we go to the extreme, it's more expensive to machine these ones with deeper pockets than with shallower pockets, because in theory it's more time. It's not much, but it's more time that it takes to make the freaking holes. And when there is no need, there is absolutely no need, and it makes the part worse. And more mass is better. AR, no, I've been off for a long time. I haven't started building this machine yet. I'm just making I'm just doing the CAD in order to achieve the modified pieces that I need so I can order them, and then I'm gonna continue with the Micron build. While I wait for the parts, and then when we finish the Micron, we're gonna actually start building the Milo. It's gonna be a very long build. So yeah, I've been playing with air guns and visit family and whatsoever. Now I'm back in business, so I'm gonna continue with the streamings. Actually, I intend to go continue every day with this CAD series until we finish the CAD, and then do 3 streams to a week to finish the Micron, and then we'll see after that. Oh, so you're gonna go into something, a gantry machine. On that size, you need to do a gantry machine. It's something more like a router. It makes no sense, Joseph. No matter where we look at it, it makes no sense. Well, I have a friend with a machine that has a bed sling of those dimensions or more actually. It should have like, yeah, I can lay down on the bed and it could machine me full size. Well, if you have any questions you can always see it again. But if you have any questions about the CAD, just ask, because I'm going kind of full speed. Hey Ezekiel, welcome. Yeah, the Milo, it's more of a specific machine. It's not the same as a 3D printer. It doesn't have that many people getting into it because it's more messy. It's different. It's a CNC machine. It's nothing like a 3D printer. Like some people may think that CNC mill, it's like a 3D print where you make the design on a computer and you press a button and the piece comes apart magically. It's nothing alike. To be honest, I was at the very beginning when I started with CNC machines back in 15 years ago. I was kind of the same. I had kind of the same mentality. I was like, okay, yeah, I buy the machine, I buy the aluminum or the material piece, the stock piece, and suddenly the machine will make everything. Yeah. Hey Jose, how are you, my friend? But yeah, it's nothing alike. So it's way more messy. Yeah, it's going, and it's not that much use to the general people. Let's be honest, it's just like that. So okay, I need to fix I need to check my extrusions, but probably not now. I need to check the size of the pieces that come here, but I don't see the point. Ah, okay, I see now. I see now. So it's when we are here, we have more space between here and here. Yeah, I see. Okay, so I'm pretty sure these pieces are longer. So where are they? That's the bed. Here. So this one should be 320. What is beeping on my computer? Oh, probably. Well, for 350, that's a good price. Five-axis machine. It's gonna be fun to make it work, but what? 350 and it came with the Mesa board? Jesus, that was a finding. Yeah. That's fine. That was a finding. Five-axis machine. Even that five-axis, it's completely, but it's fine to at least to learn. Okay, anyway, so do I need to design? No one designed the damn full metal jacket parts. Model. Yeah, there's no... Yeah, even if it's all junk, adjustable parts, it's way worth it. So this guy is gonna make me design the damn FMJ. Where did you find that? Probably. Where did you found that? Can you send on Discord the link? When user mods, this will let me see. Nope. Google Milo FMG files, okay. Oops. Well, I'm using Brave. Let me check on actual Google. And Google itself changes the shit.
Trocar voltas ao que perceber.
E dá.
Dá
Dá magia.
dá caminho,
Dá caminho que não seja sozinho.
dá janelas abertas.
Mas
Oh, my non-user modes, the shows up empty. Let me check.
Faz deste Natal um começo para os jovens do mundo novo. Vai à FNAC e doa o que conseguires para juntos mudarmos vidas. FNAC.
That's weird. Yeah, that's it. Thank you. But the question is... Okay, give me a second. I'm gonna open here. So if we go to the user modes, it shows empty. Oh, wait, doesn't show empty. Yeah, I'm stupid. Thank you. Thank you very much. Okay. Want this? Let's download it. Yeah, doesn't matter. Okay, let's upload, select files. Oh shit. Okay, I need to... Can I do this? Yep, yes I can. Since I'm working on a remote computer, I need to download it on the other computer. Give me just a second. Did I download it already? No. The fuck? Ah. There we go. Okay. Close. Upload complete. Let's see. Okay, this is supposedly parametric. Yeah, it looks like that. So modify parameters. Okay, I assume here should be 120. Okay. Let's see how long they are. So they are 474.5. Let's see if it matches what I have here. Oh, I need a tape measure. Where do I have a tape measure? Now that's a good question. That's a good question. I know I have some, and probably not just one. Just have no idea where. Where is my... So I know I have a gray one. And I believe I have a green one as well. In here. Because downstairs I have like 20. But usually in here... I have a couple as well. Nope. Nope. Jesus, I don't even know where to look. Maybe I have to go downstairs. You see here. No. God damn it. Ah, found it. No. Did it broke? Well, it didn't. Found it. Found it, found it, found it, found it. Where is the top camera? Okay, so we are supposed to have something like... Yep. Yep, that's exactly it. That's exactly it. Okay, so let's add this to the design. So this is another one. So this is the piece that joins the column to the okay, let's close these, don't save. Let's close these as well, don't save. Let's save these. We're gonna add it on the column. Will it go? Yes. No, actually it didn't. Let me select the column. Okay. So 270, let's rotate there. 19. Okay, so I assume this one should be aligned with this. Fuck, what have I done? This and this align, okay. This and this align. No, I'm gonna align this with this. Yeah, of course. So why? So these two pieces are the only pieces that connect the base, let's call it the base, with the column. Why don't they go and connect to both slots of the frame? So because this needs to go like that, now I'm gonna go do a as built joint with a Shift J, and this is actually where I know here it's supposed to take a corner and connect it to the lower piece. Oh, I'm missing too much shit already. Let me reopen. So yeah, so originally, you see, they don't come down here because of this thingy. Fine. Two things. It wouldn't be more important to connect the column better to the base, disregarding this thingy. Two, this thingy could move here. Fine. Three, you could make a dent on this thingy here too, if you really want this corner thingy in here, and put a dent and make the plate bigger and actually attach it to both like the both slots of the thingy. So see, this is stupid. It's stupid. Okay, so the back piece also connects it together, which is fine, even that is a printed part, but it's not gonna be for me. But even so, that piece should be bigger and attached on the bottom slot as well. Here you could just make another hole in there and just attach the thingy in there if it was a big problem, but it's nonsense. Anyway, this one really pisses me off as well. Almost make me want to make another 2 plates. But these are not cheap plates to make. Now I could yeah. If I move the plate down, okay, let's insert another one. Okay, this one aligns with that one, so what I'm doing here, I'm selecting one face and I'm hitting shift and selecting the face I want it to mate, and I'm clicking the right click and align components, so it will align according to what you select, the faces you select. So selecting the bottom and selecting it's not that one that I want. Okay, I can do it with this one. No, actually I'm gonna align it with this one. Let me see. Yeah, this could work. Oh no. Nope, it can't work. Motherfuckers. Yeah, because of this one. Ah, Jesus. Nope. Yeah, but I'm not gonna do new plates, I think. Especially because I'm gonna machine I'm gonna make a block for the back as well. So what I'm gonna do what I'm gonna do, it's another thing.
Smartphone de última geração, uma coluna de som, El Corte Inglês, Natal.
Yeah. These guys really piss me off. It's these little details that are... Jesus, it should be obvious. Well, the thing is, later we'll need to tram the machine. So to tram it, if you don't know what it is, first we need to tram the X and Y. Tram it means align. Make sure they are perpendicular. The X and Y are the easier ones, the easy ones. Then we need to tram the column to the table. So we need to make sure let me put it like this. So we need to make sure that the column is perfectly, it's doing this 90-degree angle here. So for that we're gonna need to adjust it for one way or another. And then we need to tram it on this way. Make sure that this angle here, it's 90 degrees. This one, it's the easier one because it's just a matter of unscrewing these screws and tilt it for one way or another. Now this one's gonna be a little finickier to adjust. We'll see when we get there, but ideally we should leave a gap I see what you mean. So basically you mean lose 20 millimeters. You mean lose 20 millimeters here. That's what you're saying. Nah, I'm not willing to do that. This thing is so short already. Yeah, when I say tram it, I say tram it to the center, to the 1000. We need to get a precision square in here with an indicator. You'll see the process, it's fun. Well, if I drop the plate down, so if I drop this plate to the floor, you see, I lose the ability. That one is fine. Yeah, nah, it's not a good idea. especially because of this singing here. It will make me lose height in here as well. Nah, it's not a... It's not a solution. Well, we'll see. But it's stupid because it's a problem so difficult to fix. But it would be so easy if they machined the thing just 2 centimeters bigger. Ah, I see what you mean. I see what you mean. Yeah, we'll see. Because this will depend on my solution as well to fix this thingy to the to the base. That's exactly why I'm making this design. Well, for now it's gonna be like this, so let me fix it. That's the point of making this design. Okay, now let's start with the fun stuff. So let's start with the fun stuff. We can do the... Okay, since I'm here, let me grab the spindle and make a model of the spindle as well. So the spindle should be this thingy. Here's my mouse. So it should be this thingy. It's kind of beefy, but it's not really. So let's just do a quick model of this thingy. So in theory, it should be 80 millimeter in diameter. Jesus, what's this? Very well machined, with shavings all over the place. So it's actually a little less than 80. It's more like 79.9. Let's call it 80. This caliper, it's not the most accurate in the world as well, so okay, like that. So let's call it 18. And we have 193 long. So 193. Then we have a step in here. To 59.3. And about 20 millimeters, 17, doesn't really matter. And then we have the ER16 thingy. We're gonna call it 25. .36. Okay, 25 diameter and 36 length. We have a square on the back here. Isn't too important. Let's do it just for the fun. So we have a square 29, 30. We can do 30. Doesn't really matter. Dirty. Let's do it coincident and coincident. That looks fine. About 20 millimeters high. And then we have some kind of circle. Which is 22 millimeters. Which is kind of centered. Point, midpoint, center. And that's it. This should be like 12 millimeters, something like that. 11 millimeters. That's the connector. That's fine. I don't care. This is just a rough representation of the spindle. It's not to win the world's most beautiful spindle. Fine, save spindle. Okay, we can close this guy. Okay, so one thing I need to or want to check in here. Actually, we can check from the both. Is inspect. Go snap. I want to check the center line from here to here. So we are talking about The fuck? Ah, okay. So we have a Z delta. Jesus, this is not even a. Okay, about 51 millimeters. That's what we need. About 51. Ok. Então.
Olá, eu sou o Miguel Carreira e podem ouvir a minha nova música Mais Cedo com o Ciro aqui no Spotify.
YouTube's gonna kill me because of the damn advertisements. Anyway, it doesn't matter. I need to check what's going on with my premium on Spotify. So what do I need? I need a bracket. I need to design a bracket for, actually 2 brackets for the spindle. Okay, so how long are these? 110. So like that. Let's make a circle of 18. Now let's make a line. 110. Let's create a point on the center of the line. And let's align. Okay, so we need from the back to the center 51. Okay, looks good. So let's make another line, big one, at the center. And let's make it a construction line. I'm thinking something like this. Let's make it perpendicular. Let's make these two at the same height, and let's create a point in here, the midline, in the midpoint, and align it there. Okay, fine, like that. So from the center to here, let's put 50. Looks good. Here maybe a little less, maybe 50 here as well. So from here to there we have 12. That's too much. We want that piece to flex there to make sure that it will adjust to the spindle just fine. So let's see, 40. 40 seems good. Yeah, 11 millimeters should be fine. Actually, we can drop these ones a little more. Maybe that's too much. Let's call it 68. Looks decent. Yeah, looks decent. Now, should I make this 2 pieces or just 1 piece? That's the question. I think 1 piece should be good, right? What am I doing? I want to edit this one. So if I cut it like that, on the center line for 3.5, so I can use a 6mm mill. And I don't know, 15 millimeters, 20 millimeters, 20 millimeters. Hey Spectra, how are you, my friend? I didn't forget about you. I'm getting time now. Okay, let's do. Let me check how they do it in the here. So for some reason they have 2 different covers. Oh, okay, so they use very, very big screws to go all the way. It's not a bad idea. Yeah, I had my fun. And I'm back now. Oh, okay, so this is for 2 different spindles. Oh, there's a smaller one. Okay, I see. So you're wiring your micron again. Okay, so what I was checking would be the diameter of these guys. So these are M5s. Okay, so let's go for 5.2. Jesus, this is a long haul. I'm not sure if I have drills long enough for this. Oops, 5.2. and create point. I could use the origin, but oh yeah, I remember. Okay, so I'm gonna use that divided by 2, and let's check the distance between the holes there. Let's move this thingy away. Inspect, show snap points. And we have 90. Jesus. Come on, not even the measurement, the damn distances are actually even. At least they are equal. Come on. These guys are really pissing me off. Let me see something else. What kind of measurement is that? Probably in inches. Well, at least it's constant. Anyway. So, how much was it? 90, right? Yeah, oh, it's late. Yeah, that's why my brain it's starting to act on me. So it's time to wrap up. Yeah, it's about 90. Jesus. Let me see. Well, I could do something fancy in here. I could do something fancy in here. But I might be crucified for it. Okay, what if, yeah, I can do that. I can do that. Well, kinda. Yeah, I don't think they are. Actually, well, we can try something. We can try something. I'm pretty sure it's the guy. I'm pretty sure it's the guy who designed it. I have absolutely no trust on the guy who designed this thing. Especially because one is right, the other is not. Actually, I haven't checked. Let me check in here. Yeah, it's the same thing. Nah. And I get sometimes those errors, but they are like in the 4th decimal case, or it's not. Nah, this is not. This is user error, I'm pretty sure. Okay, let me open. Yeah, I don't care. I'm pretty sure. Okay, give me a second. Need to find out where do I have the Milo step. So I have Casa here.
Bem-vindo ao McDonald's. Qual vai ser o seu pedido?
Mudar de rotina, sair da minha zona de conforto, arriscar mais, viver novas experiências.
É uma crispy. Menu?
Sim, se faz favor.
Já experimentaste o novo McCrispy Spicy? É que quem experimenta fica fã. McCrispy, só no Mac.
It's gonna take a while, so we can continue on the other side. Okay, so what I'm thinking may work. So what I'm thinking is, instead of drilling these things all the way, I do it like this, and I screw them from behind. So instead of 5.2, we're gonna do 4.5. Well, let's do 4.2 for the regular threads. And later I'll change it if needed. And here, how is it? It's still loading. And now, what do I want? Now I'm gonna project that on in there. And extrude 20 millimeters should be fine. Then I'm gonna go here. I'm gonna project that one. No, that one. I don't want the point. And I'm gonna put it a little bigger, 5.2. Whoa, 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 whoa. What have I written? 5.2. And now let's do 6 millimeters should be fine. Point. Project that one. See, 10 millimeters should be fine. I believe it's 9, but I like drag chains. To be honest, yeah, they should be fine for now. We'll do some refining later. There's no need for some stuff, some chamfers. That's fine for now. Let's save it as spindle mount. And let's go to our function. J. No, rigid. That's it. That's my boy. Huh. Why aren't you in here? And you too. Appropriation. Let's do another one. And let's add a spindle to it. Okay, let's align this one with this one and let's fix it. Okay, like that. Should be good for now. Yeah, I'm really sad about these plates. What a shame. I'm really sad about that shitty counterbores, which are so stupid. And oh yeah, I'm gonna feel everything I can. I'm gonna feel everything I can. So the idea, since you're late in the game, so I'm gonna save and I'm gonna end it for today. So there's a few things I wanna do. I wanna feel the whole base in here. That's one. Then about this, so let me change the appearance on this thingy again. So these are printed parts. Should be enough for now. Let me remove this, remove the handle. So the idea is also get rid of these printed parts and do some kind of filling from here to here, you see, and fill the whole thing down to the other side, on both sides, of course. So this frame in here, you see, this is a complete part, and this is another part. So in order to fill this joint, this slot, and this slot, and this slot, and fuse all the pieces together, epoxy with sand. So epoxy, some kind of epoxy granite. I can't put very large media on it because of the tight slots, but yeah, epoxy mixed with sand. Same on this side, same on all of these voids here. This joint, the joints are really important, these two joints. But yeah, filling all the hollow spots in here to make this piece way more solid. Same on the column. Fill everything where I can. So of course this main block, all the voids, fill the joints in here. I'll need to be careful because these things, I'll need to seal the ends in here. Yep, that's the idea. So in here I'm still thinking, because the way these guys made it, you see this frame, it's only attached to the base body by these 6 corners, which is ridiculous to say the least. So I'm thinking of I'm not sure what to do here yet, but my idea would be do kind of the same thing as in here, as I did here. So make some kind of mold in order to fill the from here to here, or at least from here to here, catch 2 slots. Yeah, should be enough. From here to here, and fill these to make the joint much stronger. Same on the other side. We'll deal with the drag chain later, not a huge deal. But yeah, some kind of, and the same on the bottom. If we remove this piece, fill these joints with epoxy. It's very important. I think if I fill all these joints in here, and even if I do just a single, like a single piece all the way from here to there, joined also with epoxy, would be better, a wider one. Here I need to leave this space, but that's not a problem, because these side plates need to go there. So I need to live with that. Ideally they should be all the way to the bottom, but that's another issue that I said before. I could do some aluminum brackets, a full size, but the idea and like a bunch of screws holding everything together, I think it would work well. But since the idea is to keep the price low, and the more do-it-yourself the better, I think it's way more reasonable to make some kind of dam or some kind of mold, even if a 3D printed one, to fill it will be more doable for everyone to do that and fill with the epoxy, other than me machining some custom parts and well, make it more custom. So I think I'm gonna go the epoxy route, because everyone can mix epoxy. I'm just seeing now these weird drag chain, but yeah, it's cool. Concrete should be fine. I just don't like the concrete doesn't adhere as well as the epoxy, and it's more rigid, it's less, it doesn't absorb the vibrations as well, but it will definitely not bond with the aluminum, while the epoxy will completely glue to it. But yeah. Okay, so that's it for today. Wasn't a bad day. So see you tomorrow at the same time, more or less. We're gonna continue tomorrow with the CAD of this thingy. So again, the idea is to get to the changes I need to do, so I can actually see what stuff I need to order, so I can order. And while I'll need to order stuff from China, like the ball screws essentially, and the ending blocks, the coupling blocks, whatever you guys want to call it. So the idea is to get everything sorted out so I can order. Then while we wait for the stuff to come in, I can actually start working, I can continue working on the Micron. And eventually when we have everything prepared and everything set, we can start to build the Milo. So let's just check real quick the on SolidWorks, if it's a measurement, if it's a translation problem from Fusion, so converting from step to models in Fusion, those weird measurements, but I don't think so. I'm very, 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 very confident that's a design problem. Sure. When I usually the main issue here, I'm gonna go with FF and FK blocks and 1204 ball screws. What I really need to get into, it's the dimensions of the ball screws and the design. I'm not gonna use the oh, okay. Oh, okay. But I usually find those mistakes, yes, true, but they are way smaller than this. Usually are like in the sub-micron stuff. And in this case we were seeing like 2 to 68 microns. That's too much. Sometimes I get those mistakes, like it doesn't even have a decimal point. It goes to the exponential, to the scientific thingy. 10 to -8 or something order of magnitude. So I don't think it's or is Fusion is here. So I don't think it's Jesus, it's been so long. Isolate. So supposedly, go away. Evaluate, measure. Why aren't you snapping? Okay, if I go here to here. Okay, center to center. From this center to this, come on. Come on. Okay, so here, yeah, we have the 90.07. That's exactly what we had on. And here we have the 90 even, so yeah. I'm pretty sure it's a design fault. It's not a fusion thing on here. Especially on these, if we go from here to here, like 78.64. This is like nothing. Doesn't look like anything. So yeah. So yeah, guys, thank you very much for keeping up with me. Thank you for watching, and see you guys tomorrow. Hope you guys learned something. Hope you guys enjoyed. And yeah, that's gonna be it for today. I'm tired. It's kind of a little later than I was expecting, but I was on a rampage. So we'll see you tomorrow. Have a good night and take care. Bye bye.